Welcome to the introductory presentation on operation and maintenance of the Godwin Dri-Prime pump set. During this presentation, information will be presented on equipment design, including the pump set, suction and discharge hoses and fittings, pre-startup checklist items, pump system setup and operation, system shutdown and disassembly, troubleshooting, and routine maintenance. The design of the Godwin pump set contains a pump end, drive unit, either diesel or electric, and a mounting which can either be trailer or skid. The model shown in this presentation is the 6-inch CD150M, which is powered by a diesel engine and mounted on a highway trailer. The trailer is designed so that the pump set can be safely towed behind a vehicle at normal highway speeds. The Godwin Dri-Prime pump set is a surface-mounted, solids-handling portable trash pump set that utilizes a venturi priming system to evacuate the air from the pump housing and suction hose. The evacuated air reduces the atmospheric pressure in the hose and lifts the product into the pump housing. This process begins when the engine is started. A belt-driven air compressor mounted on the pump bearing bracket delivers compressed air to the venturi. The high-velocity air rushing through the venturi evacuates the air in the pump body and suction housing, while a large ball in the non-return valve seals out air from the discharge hose and piping. Prior to using the pump, a vacuum pad test should be performed to confirm that the venturi is operating properly and is capable of evacuating air and raising product into the pump. To perform the vacuum pad test, the diesel engine must be started. The control panel on the diesel engine contains gauges that show the operation of the engine. They include the tachometer, which displays the speed of the engine and pump end, the hour meter, which records how many hours the engine has run, the oil pressure gauge, the water temperature gauge, and the ammeter showing the activity of the alternator. Certain safety features are built into the diesel engine control panel. On the oil pressure and water temperature gauges, pins are set to shut down the engine if certain extreme conditions exist. The oil gauge pin is set at 20 psi, which means if there is an oil leak in the system and pressure drops to 20 psi, the gauge needle will touch the pin and the engine will shut down automatically. Likewise, the water temperature pin is set to 240 degrees Fahrenheit, meaning that if the temperature in the cooling system rises to that level, the gauge needle will touch the pin and the engine will shut down automatically. Prior to starting the engine, several key fluids should be checked. Open the fuel tank cap and check the fuel level. Then open the radiator cap and check coolant level. A warning: be sure the engine is cool before opening the cap. Then check the oil level in the pan by pulling the dipstick and making sure that there is a sufficient amount of good quality oil in the engine. Next, check the quantity and quality of the oil bath mechanical seal oil by unscrewing the fill cap on the oil bath chamber. Use the engine oil dipstick to check the oil bath chamber. The oil should be clear and the chamber should be filled to within about a ½ inch of the top of the fill port. After replacing the engine dipstick, the engine's ready to be started. On the control panel, there is a button located below the ignition key switch. It's commonly called the tattletale button. During engine startup, the tattletale button must be depressed for the engine to start. The button temporarily overrides the low oil pressure shutdown pin until the engine creates oil pressure greater than 20 psi. To start the engine, depress the tattletale button and turn the ignition switch to the right or start position. Once the engine starts, let the key move back to the on position and watch the oil pressure gauge. When the needle reads above 20 psi, release the tattletale button and the engine should continue to run. The RPM of the engine can be adjusted by turning the throttle handle counterclockwise until reaching a normal operating speed of 1800 RPM. Now that the engine pre-startup checks have been done, the engine can be started and the vacuum pad test can be performed. To perform the vacuum pad test, do the following. Check that the volute drain valve is closed. Check that the vacuum pad ball valve is closed. Then start the diesel engine. Raise the RPM to approximately 1800. Place the vacuum pad on the suction connection. Wait until the needle on the vacuum gauge rises to its highest point and holds. Reduce the RPM to idle. Shut down the diesel engine by turning the key switch to the off position. Observe the vacuum pad needle for movement. Finally, open the vacuum pad ball valve to break the vacuum. A successful vacuum pad test will read between 23 and 25 inches of mercury at sea level. That would be equivalent to a 25 to 28 foot suction lift. A quick way of converting vacuum pad readings to lifting capabilities is to add 10% to the vacuum pad reading to get an approximate reading of lifting capabilities of product. Vacuum pad readings will be less at higher altitudes, which will also affect suction lift capabilities due to the lower atmospheric pressure. Once a successful vacuum pad test has been completed, the pump set is now ready to be put in service. When setting up the pump system, position the pump set as close to the source of product as possible. Lower the front and rear jack stands and level the pump set using the crank handles. The Godwin Dri-Prime pump with the Venturi air evacuation priming system is capable of lifting product up to 28 feet to the eye of the impeller, which is normally about 3 feet above the ground. If the suction lift is greater than 28 feet, then a submersible pump such as the Godwin Hydra hydraulic submersible or the Godwin subprime electric submersible pump will be required. If the lift is less than 28 feet, position the pump and then connect the suction hose to the pump set. When connecting the suction hose, make sure that connections are clean and free of debris. The fitting system used in this presentation is the Godwin Quick Disconnect Fitting System, or QD for short, which utilizes a ball and socket type joint. When connecting the QD joint, check to see that the O-ring is in good condition and that the ball doesn't have any dents. Both of these conditions can allow air into the hose and prevent the pump from achieving vacuum and prime. To connect the QD joint, angle the hose so that the ear without the handle can be connected to the female fitting. Then move the hose so that the other ear can be connected and retract the handle by flipping it over. Using a crescent wrench helps provide leverage when closing the joint. Each QD joint allows up to 20 degrees of deflection on 6-inch and larger fittings and up to 30 degrees deflection on 4-inch joints. A suction screen is always connected at the end of the suction hose to screen out solids that are larger than what the Dri-Prime pump can handle. Internal damage to the pump can occur if the screen is not connected and a large solid enters the pump housing. Once the suction hose and screen have been connected, position the hose in the product to be pumped. Next, the discharge hose is connected from the pump set to the delivery point. Discharge hose or pipe can be connected directly to the pump discharge fitting, or several fittings can be used to help lower the product to ground level. Here, the Godwin step bow is being used. The step bow is a rigid pipe with 2 offsets that lowers the product to ground level. This helps alleviate wear on lay-flat hose when it hangs directly off the discharge connection. When connecting QD fittings, it is important to remember that the flow of product always goes from the male fitting into the female fitting. That's why Godwin Dri-Prime pumps outfitted with QD connections have a female fitting on the suction side and a male fitting on the discharge side of the pump. Now that the suction and discharge hoses are in place, the system is ready to be started. The pre-startup checklist is similar to the one used on the vacuum pad test. First, check that the front and rear jack stands are lowered and the pump set is level. Then check the fluids in the engine, the fuel, the coolant, and the oil. Check the oil in the oil bath mechanical seal chamber. Check that the pump volute drain valve and the non-return drain valve are closed. Next, start the diesel engine and raise the RPM to approximately 1800. Once the system is primed, reduce the RPM to an operating speed based on the application. Finally, check for any fluid leaks in the pump set or the drive system, such as the product being pumped, or fuel, coolant, or oil leaks. The actual time to achieve prime will depend on the length of the suction lift and the amount of suction hose that is used. Most 4-inch and 6-inch pump systems will prime within a minute. During operation, there may be a small amount of product exhausted with the air out of the leak-off hose located below the suction hose connection. This is normal. If the product needs to be contained, merely extend the length of the leak-off hose and direct the product back into the source. There may be times when the pump will not be pumping any product at all due to the changing flow conditions. The oil bath mechanical seal design keeps the mechanical seal in the pump cool and lubricated even when there is no product being pumped, which means there's no need for an operator to watch the pump set during normal operation. Shutting down the system is fast and easy. First, reduce the RPM of the diesel engine to idle. Then turn the engine off by moving the key on the control panel to the off position. There are 2 drain valves on the pump set that should be opened after the equipment has been shut down. The first drain valve is on the pump volute. Opening this valve will allow product in the suction hose to drain back into the suction pit. The second drain valve is on the non-return valve located on the discharge of the pump set. Opening this valve will allow air to enter and the discharge line to drain. An important note during freezing weather conditions: always drain the volute and non-return valve after operation in freezing weather. If water is allowed to stay in the volute and non-return drain valve in freezing conditions, the water will turn to ice and expand, possibly causing damage to the cast iron pump volute and non-return valve. The system is disassembled in the same way that it was assembled. Once the suction and discharge lines have been drained, loosen the QD fittings at the joints of the hose and pipe. Troubleshooting the Godwin Dri-Prime pump. The Godwin Venturi air evacuation priming system is a fast, reliable way of removing air from the suction of the pump application and bringing product to the pump for priming. In the event that product does not rise to the volute, several quick and easy things can be checked to correct the situation. Going back to the vacuum pad test, if the pad shows no vacuum reading at all, one of 2 conditions exists. 1. Air from the atmosphere is entering the body of the pump. Or, there is no compressed air being delivered to the venturi priming system. In the first instance, air from the atmosphere is entering the pump. The most common cause of Dri-Prime pumps not priming is air entering the pump body. Air can enter the pump body from several locations. The first and easiest thing to check is the volute drain valve. If the drain valve is left open accidentally, the priming system will not be able to create vacuum. The next thing to check is the non-return valve ball and seat. If a piece of debris that has been pumped gets lodged between the ball and the seat, air from the discharge will enter the pump and keep it from creating a vacuum. Remove the top lid and lift the ball to inspect the ball and seat for debris. After it's clean, reassemble the non-return valve by putting the lid on and tightening down on the eye bolts. Another area to check is the screen located below the venturi housing. By loosening the 4 nuts on the top of the housing, the venturi priming system can be lifted up. The screen separates the pump from the venturi priming system. If the screen is filled with debris, air will not be able to pass through during the air evacuation process. After inspecting and cleaning the screen, replace the priming housing and tighten the 4 nuts on the studs. Be careful not to over-tighten the nuts because gasket damage could occur. Snugging them up is good enough. Finally, check the valve deck of the air compressor to see if there might be carbon fouling. This can be checked by removing the venturi and inspecting it for carbon buildup. To remove the venturi, use a crescent wrench to back the shoulder retaining bolt from the edge of the venturi housing and pull down the venturi. The O-rings on the venturi itself that help seal the vacuum will provide some resistance when pulling on the venturi. The venturi fouled with carbon is an indication that the valve deck needs to be maintained. Clean the venturi while it is pulled and then replace it in the holder by pushing up until it seats. Tighten the shoulder bolt to keep the venturi in place during operation. Routine maintenance of the Godwin Dri-Prime pump. It is recommended that the diesel-driven Godwin Dri-Prime pump set be fully serviced every 250 hours. Suggested practice is to write the date of the servicing and the hour total from the starter panel in a dry ink pen on the oil filter at the time of changing. This serves as a reference point for future servicing. A routine 250-hour servicing includes the following items. On the pump set, shine a flashlight into the pump suction and look for signs of wear and pitting. Using feeler gauges, check the clearance between the front wear plate and the impeller. The clearance at the factory is set at 25 thousandths of an inch. Consult the pump maintenance manual for instructions on adjusting the front and rear wear plate clearances. Next, pull the venturi. Inspect and clean it. If it has excessive amounts of carbon buildup, air compressor maintenance should be considered. Remove the priming system and check and clean the screen. Check the condition of the venturi ball in the priming housing. The ball should be free and loose without nicks, cuts, or splits. The round brass retainer ring can be unscrewed to gain access to the ball. Replace the priming housing and tighten the 4 nuts on the studs. As mentioned before, be careful not to over-tighten the nuts because gasket damage could occur. Snugging them up is good enough. Remove the fill cap on the oil bath mechanical seal chamber and check the quantity and the quality of the oil. If the oil is excessively white in color, the mechanical seal may have failed. Consult the pump maintenance manual for instructions on seal inspection and replacement. To finish off the servicing of the pump end, replace the air compressor inlet air filter. On the diesel engine, drain the oil from the oil pan. Replace the oil filter. Again, suggested practice is to write the date of the servicing and the hour total from the starter panel in a dry ink pen on the new filter. This will serve as a reference point for future servicing. Then drain and replace the fuel filter. Replace the inlet air filter. Perform an overall check of belts, wiring, and coolant. On trailer-based pump sets, check the wheel bearings and grease as necessary. Then check the inflation of the tires. Next, check the jack stands and adjust, repair, or replace them as necessary. Next, check the pintle hitch and safety chains and clips. Also check the lights on the trailer if it is so equipped. Record all maintenance activities for future reference. Let's recap the information covered in this presentation. Pre-startup. Prior to starting the diesel engine, check the engine oil level with the dipstick, and also use the dipstick to check the level in the oil bath mechanical seal. Start the engine and perform a vacuum pad test by placing the pad on the suction fitting. Remember to close the volute drain valve. If the vacuum pad reads between 23 and 25 inches, the priming system is working correctly. System setup. Position the pump as close to the source as possible. Lower the front and rear jack stands and level the pump. Connect the suction hose using a screen at the end. Connect the discharge hose or pipe to the delivery point. Start the engine by turning the key to the start position and depressing the tattletale button. When the engine starts, move the key back to the on position and release the tattletale button when oil pressure has been established. Adjust the RPM of the engine so that the pump keeps up with the maximum flow of product into the suction hole. System shutdown. To shut down the pump set, reduce the engine to idle speed, then turn the key to the off position. Open the volute and non-return valves to allow the suction and discharge hose and pipe to drain. Finally, disconnect the suction and discharge hose and piping. A quick review of troubleshooting. First, perform a vacuum pad test to diagnose the problem. If the vacuum pad test is successful, the problem is most likely a plugged screen or a vacuum leak on the suction hose. If there is no vacuum, check to see that the air compressor dry belt is attached. Check that the volute drain valve is closed. Check the non-return valve ball for proper seating. Check the venturi for carbon buildup, or check the venturi screen for debris. Most priming problems will be solved by following these simple steps. Finally, to recap the servicing, every 250 hours, replace the following items: the air compressor inlet filter on the pump set, the engine oil filter, engine fuel filter, and engine air filter. Also check the following: impeller wear and clearance at the pump suction, venturi and venturi screen, the quantity and quality of the oil bath mechanical seal oil, the non-return valve ball and seat, engine belts, wiring, and coolant, trailer wheels, lights, pintle hitch, and safety chains. The Godwin Dri-Prime pump is the most reliable and well-designed portable pump on the market today. Proper operation and maintenance can help ensure years of successful portable pumping in all sorts of applications.